Okay, so we're going to have a look at equations of tangents to circles. Now this is quite a tricky topic, there's quite a lot going on, so make sure you've checked out all the previous videos in this series, which are linked in the description. But grab a piece of paper, grab a pen, make some notes, because we've got quite a lot to cover here. And also I've got something to show you at the end, a little app that you can use just to help you visualise these as well. So stick with it, and yeah, let's get started with this question. So find the equation of the tangent to the circle at 3, 4. Now a lot of the time you won't be given a diagram, but as I started the last video looking at this circle here, I thought I'd start with the same one. So this circle here obviously has a radius of 5, which we can see down there. We could write the equation of this circle as well. It'd be x squared plus y squared equals the radius squared, so 5 squared is 25. We don't need it for this question because we're finding the equation of the tangent. There's just something to be thinking about, obviously from the last video there. So let's have a look. If we want to draw in this tangent, let's just imagine where it would be. A tangent obviously being a line which just touches the edge of this circle. So the point 3, 4 is here. So if we had to draw a tangent in, and it's not the easiest for me to draw, but if I try and draw part of it in, it would look something like that. Not very good there because it's not actually touched the circle. I'll try again. Let's have a look. Okay, probably worse there, but there we go. Just something to give you a little bit of a visual idea as to what it would look like. Now, if we want to find the equation of that tangent, the equation of any line, we're going to need to work out what the gradient is. Now, at the moment, we have nothing that we could actually go use to work out the gradient of that line. We only have this one coordinate here, 3, 4. So if we want to get the equation of the tangent there, we need to find the equation of something else, or the gradient of something else, and that line that we're going to find is the radius. So obviously all these circles are centred at 0, 0 at the origin, and the radius is perpendicular to the tangent. Okay, so it forms a right angle over here. Okay, and we've obviously looked at perpendicular lines in the previous video, so we'll know what to do if we can find the gradient of the radius there. Now, to find the gradient of the radius, it's actually quite nice and simple, because we're going from the coordinate here, which is 0, 0, and that connects up to this point here, which we've been given 3, 4. And we don't have to draw a little right angle triangle in here, but if we imagine finding the gradient of this, let's have a look. Let's see what our change in y and change in x is. Now it goes from 0 along to 3, so that's a change in x of 3, and it goes from 0 up to 4, so that's a change in y of 4. And as all these circles are centred at 0, 0, it's always nice and easy because it's just those two numbers within the coordinate there, the 3 and the 4. So if we work out the gradient there, the change in y over the change in x is 4 over 3, and that's our gradient of the radius. Now that allows us now to get the gradient of the tangent. Because the tangent is perpendicular, we can do our perpendicular gradient, which is our negative reciprocal. So stick it with a minus and flip it over, so minus 3/4. Now it does happen to be that a lot of these, the gradients aren't the nicest. They do tend to be fractions or negative fractions, and they're never the nicest ones, but that's why it's a trick now, you know, one of these harder topics here. So let's have a look. Let's put that into our line equation. So y equals negative 3/4 x plus c, and then from there we just need to find a coordinate that's on the line, and that's great because that's been given to us there, the point where it meets the tangent, the point where the circle intersects there with the tangent, 3, 4. So we're going to sub in this coordinate 3, 4, and let's see what we get. So 4 is y, and that's negative 3/4 multiplied by the x coordinate, which is 3, plus c. Right, so tidying that up then, negative 3/4 times 3, remember that's 3 over 1 there, so just timesing it like a normal fraction. So 4 equals 3 times 3 on the top, which is 9, and 4 times 1 on the bottom, which is 4, plus c. There we go, and we just need to tidy this up now to get our value of c. Now just a little side note, obviously whenever you get fractions involved here, if you don't have a calculator, just turn them into a mixed number. So that's negative 2 1/4. Okay, 4 goes into 9 twice with the remainder 1, negative 2 1/4. So if we add 2 1/4 over to 4, we get 6 1/4. So solving that for c, we get 6 1/4 equals c. And now we can put that in place of the c at the top there in our equation. So finishing this off for our equation, I've not got much space here, so let's just try and fit it in. We've got y equals negative 3/4 x plus 6 1/4. There we go, and there's our final answer, and that's the equation of our tangent. Right, okay, we're going to follow a very similar process. We're going to look at a couple of these, as it is quite a tricky topic, okay, but let's just think about the steps we just did there. So we first found the gradient of the radius. Because the radius is perpendicular to the tangent, we could then do our negative reciprocal, and then actually we just followed the same steps from the previous video, which is just using that gradient, subbing in the coordinate, which is where it intersects, and then just solving that for c and writing our equation of the line there. Okay, just a few little tricks there with the fractions when it comes out as a mixed number or something like that though. Let's have a look at another one. Okay, so find the equation of the tangent to the circle with equation x squared plus y squared equals 5 at the point 1, 2. Now you don't have to have a picture for this, it can sometimes just help just to visualise it, to just draw a little sketch. They're all centred at 0, 0, so we can just draw a little sketch. Doesn't matter if it's any good or not. 1, 2 will be in this quadrant here, and then we can draw part of the tangent there, and we can just label it up. So 1, 2, obviously centre 0, 0. There we go. And we can use that to try and help us visualise this. So we are going to find the gradient of this radius here, which we can do by drawing a little right angled triangle in. So the rise goes from 0 up to 2, and the run goes from 0 to 1. So we can just use that to find our gradient now. So the change in y over the change in x is 2 over 1. There we go, that's quite a nice one because that's just 2. So our perpendicular gradient, doing our negative reciprocal of 2, remembering again that 2 is just 2 over 1, so it becomes 1 over 2, and swapping to a negative. So there's our gradient. And again, from here, it's pretty much the same steps as on the previous video there. So let's just have a look. We've got y equals minus a half x plus c, and then our coordinate is 1, 2. And if we sub that in, let's see what we get. We get 2 equals minus a half times 1, which is just minus a half, so I won't bother writing that in, plus c. Add the half over, we get 2.5 equals c, and that's fine to leave it as a mixed number. And now we can just write our equation, just replacing c with 2.5. So y equals minus a half x plus 2.5, and again you can write these as decimals if you want. You could write minus 0.5x plus 2.5. Okay, likewise you could even write 2.5 as 5 over 2. You can leave it as a top heavy fraction if you want, or in proper fraction. Absolutely fine for you to do. As you can see, that one there was a little bit nicer than the last one. Okay, so just showing you that they're not all that nasty. Still obviously a difficult topic, but that's a nicer version of one of these questions. We'll have a look at one more before you have a go. Okay, so find the equation of the tangent to the circle with the equation x squared plus y squared equals 29, but at the point negative 5, 2. So thinking about what this one looks like, okay, just draw a little sketch. And negative 5, 2 is going to be over here in this quadrant. Okay, negative 5, 2. So if I was to draw a little tangent, it'd be sloping this way this time. There we go, so let's label that up. Minus 5, 2. And again, centre 0, 0. And again, let's think about what this would look like. So drawing in our gradient, our radius, sorry, and thinking about what the lengths are this time. Now, obviously, the gradient of the radius this time is going to be negative, look, because the radius is actually sloping downwards. So let's have a look at what we get. So the change in x goes from negative 5 to 0, which is positive 5, and the change in y goes from 2 down to 0, so that's minus 2. There we go, so that's why we're going to get our negative gradient here as well. So the change in y over change in x is negative 2 over 5, which means we can get our perpendicular gradient again. So flipping it over gives us 5 over 2. And again, it turns it from negative to positive. There we go, so not too bad. Now we can put that into our line equation. So y equals 5 over 2x plus c, and then we can go about subbing our coordinate in just like before. Right, so our coordinate this time is negative 5, 2, and if we sub that in, what do we get? We get 2 equals 5 over 2 multiplied by the x coordinate there, which is negative 5, plus c. Expanding that out to tidy it up, 2 equals, don't forget that's negative 5 over 1, so it's minus 25 over 2, plus c. And again, we've got this scenario here where we have an improper fraction. So if we make that into a mixed number, 2 goes into 25, 12 times remainder 1. So that's negative 12.5 or negative 12.5, and we can add that over to 2 nice and easy. And if we add that over to 2 to solve this as for c, we get 14.5 or 14.5 equals c. Right, now we can put that in place as c up here. Now again, it wouldn't be wrong to do so, but I'm going to keep it consistent with my fractions here. So the 5 over 2 there, I'm going to turn that into a mixed number and keep it all consistent. I could turn it into decimals if you like, but as long as I keep it consistent. But actually, it wouldn't be wrong to leave one as improper and one as a mixed number. So y equals 2.5x. 2 into 5 goes twice, remainder 1. So 2.5x or 2.5x plus the 14.5. And again, you wouldn't be wrong to leave one as an improper fraction and one as a mixed number. I just personally don't like it when they are mixed up, but you're absolutely not wrong to do so. Likewise, we could write y equals 2.5x plus 14.5 as a decimal. There we go. So they're the steps. You need to find the gradient of the radius, which remember always goes from 0, 0. So it's actually just the y coordinate over the x coordinate at that intersection. Then do your perpendicular gradient, so your negative reciprocal. Put it into y equals mx plus c. Sub in your coordinate, solve it for c, and then write the equation of the line. Okay, so lots of steps there, so hopefully you've made some good notes on this. Right, here's a couple for you to have a go at. Okay, so here's 2 questions, so pause the video there, have a go, and we'll go over the answers in a sec. Right, okay, so the first one. Now the gradient of the radius in the first one, I'm not going to draw a diagram for both of these, is 3 over 4. So your perpendicular gradient is negative 4 over 3. Then let's have a look at the next bit. Right, so putting that into your line equation, y equals minus 4/3 x plus c, and then putting in our coordinate 4, 3 up there. So let's sub that in. What do we get? 3 equals minus 4/3 multiplied by 4 plus c. There we go. Let's expand that out. So 3 equals minus 16 over 3 plus c, and then 16 over 3, let's rewrite that as a mixed number. 3 goes into 15, so it's minus 5 and 1/3. And if we add that over to 3, we get 8 1/3 equals c, and now we can put that in place of c to finish this off. So we have y equals minus 4/3 x plus 8 1/3. And there's our final answer for that question. On to the next one, following the same steps. We've got a coordinate 2, 6. So the gradient of the radius will be 6 over 2, which is 3. So the perpendicular gradient will be negative 1/3. There we go, plugging that into our line equation again. Y equals negative 1/3 x plus c. And then subbing in these coordinates, so 6 is y, so 6 equals minus 1/3 multiplied by the x coordinate 2 plus c. And if we tidy that up again, we get 6 equals minus 2/3 plus c. And then we can add that over. We don't need to convert that into a mixed number this time, but we can add it over. So add 2/3 onto 6. We get 6 and 2/3 equals c, and then again we can put that in place of c and write our line equation. Okay, so y equals, and we've got our perpendicular gradient of minus 1/3, so minus 1/3 x, plus our c value there, which is 6 and 2/3, and there we go, that's the final answer for the equation of this tangent. Now, of course, you could write that 6 and 2/3 as a top or as an improper fraction as well. That's absolutely fine, but it's absolutely fine also to leave it as a mixed number there, but perfectly fine if you want to change it or swap the pieces around so that you have 6 and 2/3 minus 1/3 x. That's fine as well. But there we go, that's the end of those 2 questions. Let's have a look at something else. Okay, so find the equation of the tangent to the circle with equation x squared plus y squared equals 17 at the point 1p, where p is positive. Hence find the coordinates where the tangent intersects the x-axis. So there's 2 extra steps here. We've not got the coordinate where it intersects, and it's also asking us to find where it intersects the x-axis. So we're going to take this in steps, but let's have a think about what this would look like to start with. So we know it's a circle. We know its centre 0, so we can draw a little sketch, even if it's not very good. There we go, and we can think about where this coordinate is. So 1p, where p is positive, is going to be over here in the positive quadrant there. So let's have a look, let's draw that in. Okay, let's just draw a little sketch of this. So that coordinate is 1p. I'm not going to write the p in for the moment because we're actually going to figure that out. And then we know it's centre 0, 0. Obviously, we're still going to be looking at finding out the gradient of the radius here. But we've got the tangent going down. It's intersecting the x-axis over here. So this here is where it intersects the x-axis. So this is what we're looking for here, this coordinate. And that's what we're going to find in a sec. So let's have a think about this. Now we can't find the gradient of the radius unless we know that coordinate there. So we can use this equation of the circle to find that coordinate. As we looked at with equations of circles, if this is definitely on the circumference of the circle, then it has to balance within that equation. So if we sub this coordinate into the equation, let's see what we get. 1 squared is 1 plus y squared, which we don't know. We could call it p squared if we want. And that equals 17. And if we solve that, so take away 1 from both sides, the 1 squared, we get y squared equals 16. And then the square root of that to get y is going to equal either 4 or negative 4. Now it says that p is positive, so it's got to be the positive 4 there. Again, if it didn't tell us that p was positive, we'd have to have a diagram to know whether it was there, otherwise it could be either. But in this case, it does say p is positive, so p is 4. So there we go, we've got our coordinate for y there, 4. Now we've got that, now we can find the gradient of the radius. Okay, so we can draw in our little right angled triangle again, we can find the gradient and we can follow all those other steps. We will have a look at this last step though at the end, the coordinates where the tangent intersects the x-axis. That's going to be our final step, but first if we find the equation of that tangent, we'll be able to use that to find that intersection point with the x-axis there. So following our normal steps, let's find the gradient. So the gradient is from 0 to 1, 4, so that's going to be 4 as our change in y over 1, which is just 4, and our perpendicular gradient, negative reciprocal, minus a quarter. There we go, now we can plug that into our line equation. So y equals minus a quarter x plus c, and let's sub in this coordinate. So we've got 1, 4 to sub in, so 4 equals minus a quarter times 1 is minus a quarter, so that's quite a nice one, minus a quarter plus c, and then adding a quarter to both sides, we get 4 equals, sorry, I've not actually added the quarter over, add the quarter over, we get 4 and a quarter equals c, and then from there we can write our line equation, plugging that value into c up there. So we get our line equation as y equals minus a quarter x plus 4 and a quarter. There we go. And obviously up until this extra step, that's what we've been doing on the previous questions there, with the extra step of actually finding the coordinate. Well, that wasn't too tricky in this step here, just to get y equals 4. So now it says find the coordinates where the tangent intersects the x-axis. Now this is something that always tends to throw people, but right here, this coordinate, we actually already know one of the coordinates there. We don't know the x coordinate, obviously, but we do know the y coordinate. Okay, the y coordinate has to be 0. Okay, because it's on the x-axis. You think about the y-axis over here, this is 0, we already know 0, 0 there is on the x-axis, so the y coordinate has to be 0. And because we know that we can sub 0 in place of y here in our equation. And if we do that, so we know y is 0, we can have 0 equals minus a quarter x plus 4 and a quarter. There we go. And that we can only do that because we know the y coordinate at that point. Now we just have the one unknown in our equation, we just have this value of x, so we can try and solve this for x. So if we subtract for this 4 and a quarter from both sides, we get minus 4 and a quarter equals minus a quarter x. And then we can divide both sides by negative a quarter. So we've got 4 and a quarter divided by negative a quarter. They're both negative, so our answer is going to become positive, which we know it's going to have to be positive as it's over in the positive quadrant there. And if we divide by negative a quarter, well, a quarter fits into 1 4 times, so it must fit into 4 16 times, plus the extra quarter there gives us 17. So if we solve that, we get x equals 17. Okay, that's just me doing negative 4 and a quarter divided by negative a quarter. Again, if you've got a calculator, that's nice and easy, but just remember a quarter fits into 1 4 times, so it has to fit into 4 16 times plus the extra 1 there, which is 17. So the coordinate there is 17, 0. And that'd be our final answer there, 17, 0. There we go. Lots going on that question there. And again, don't forget, you could always use your fraction rules. If you didn't have a calculator, it wasn't a nice easy one, you could do, let's have a think how we would write that. The negative 4 1/4, we could make that top heavy. So 4 times 4, 4 big times the bottom is 16, plus the 1 is 17, so it's negative 17 over 4 divided by negative 1/4. And you could just apply normal fraction rules to that. So keep the first one, flip the second one over, and then simplify it. So you do 17 over 4 multiplied by 4 over 1, and then obviously just simplify it from there. So there are other steps you could take if it was particularly nasty, but let's have a go at trying one of these out. Okay, so here's your question. You've got your equation of your circle over here, x squared plus y squared equals 29. You've got at the point 2p, where p is positive, and it wants you to find the coordinates where the tangent intersects the x-axis. So draw yourself a little sketch. Okay, remember it's circle centre 0. Okay, doesn't matter how good it is. Draw yourself your little tangent, remembering where it is, in the positive quadrant there for this one. And remember that you are trying to find this coordinate just here. So you have your one coordinate, which is 2 and something, and you have your centre 0, 0. Okay, so there you go. Have a go. Pause the video there, see what you get, and we'll go with the answer in a sec. Right, okay, so let's have a think. We've got to get our y coordinate here. So if we sub that in, we get 2 squared plus p squared, or the y squared, and that has to equal 29. 2 squared is 4, so if we take that away from both sides, we get y squared equals 25. And then the square root of 25 is positive or negative 5, but we know it has to be positive, so y has to equal 5. So let's stick 5 into our equation over there, into our coordinate, sorry. There we go, so 5. Now we can get the gradient of the radius, so connecting that up, drawing a little right angled triangle, which has a rise of 5 and a run of 2. So our gradient there, m equals 5 over 2. So our perpendicular gradient is negative 2/5. There we go. Now we've got negative 2/5, we can put that into our line equation. So y equals negative 2/5 x plus c. And now we can sub that coordinate in. We've got 2, 5. We've completed that now, so we can put that into our equation. So 5 equals negative 2/5 times 2 is negative 4/5 plus c. And then you can add 4/5 over to the other side. So we get 5 and 4/5 equals c. There we are. And now we can put that into our actual line equation there in place of c, so we have our equation of the line. So we have y equals minus 2/5 x plus 5 and 4/5. There we are, and there's our line equation. Now we're finding that x coordinate, so we know at this point here one of the coordinates there, which is y equals 0. So if we plug 0 into our equation and see what we get 0 equals minus 2/5 x plus 5 and 4/5, and then we just need to solve this. So not the nicest again. If we subtract 5 and 4/5 from both sides, we get minus 5 and 4/5 equals negative 2/5 x, and then we need to divide both sides by negative 2/5. So again, we can think about this one quite logically. But let's have a think about actually going how we would go about this. So minus 5 and 4/5 is, if we make that top heavy, negative 25 plus the 4, 29/5, minus 29/5, and we're dividing that by negative 2/5. So let's get rid of this diagram. We're going to need a bit of space to work this out. Okay, so we have this scenario. We've got negative 29/5 divided by negative 2/5, and that's going to equal our x coordinate. Now let's just imagine they're both positive, as it's negative divided by negative, and let's just apply normal fraction rules. So we've got 29 over 5 multiplied by the reciprocal of 2/5, so 5/2. And again, this is nice and easy if you have a calculator, but we don't on this particular scenario. So 29 times 5 is 145, and 5 times 2 is 10. And then if we simplify that, let's see what we get. Top and bottom both divide by 5. So let's have a think. How many times does 5 go into that? Is that 14, 28, 29 over 2? And again, this could very likely be a calculator question, but it's always good just to practice these skills. So let's just check this out. 29 times 5, we've got all this correct, 145, and 29 over 2, we can halve that. I could just leave it as a fraction, but it's 14.5 if we write it as a mixed number. Okay, so it's 14 1/2. There we go. 14.5. So a little bit harder than the last one, obviously because our x coordinate there is a decimal or a fraction there, for whichever way we want to look at it, but it's 14.5, 14.5. So we can write our coordinate now, which is 14.5 and 0. And there we go, there's our final answer. Okay, quite tricky question there. Obviously that final step was a little bit harder than the one I just did. Obviously having to just think about your fraction division rules and just being very careful with that. But nothing too horrible there, just had to obviously be careful with your simplifying and getting that down to 14.5. Again though, this is a very tricky question. You are looking at sort of your last page sort of question on an exam here. So it is meant to be tough, it is meant to be tricky. You know, it's pushing onto those sort of grade 9 skills there. So, right, we're going to have a look at one more style of question. Okay, so I thought at this point it'd be worth just showing you this little program. So it's called Desmos. You can go on the internet to find it, or you can just download the app, it's free. But I just wanted to show you this. It just does just help with these sorts of questions when you're practicing any of these. The fact that you can just type it in and have a look to see if you've got it right is quite nice. So if we go ahead with that last question, now the equation of the circle was x squared plus y squared equals 29. There we go, and that's the equation of our circle there, and it's quite nice. You can sort of zoom in and have a little look at it. But there's our circle equation. Sorry, I've not actually put 29, I put 22. There we go, there's our circle equation. Right, so that's the equation of the circle we were looking at. The equation of the tangent, we found it out to be y equals negative 2/5, so minus 2/5, x plus 5 4/5, plus 5 and then 4. Okay, that's not very nice. It doesn't like me doing that. Let's have a look. 5 and where's the space button? Okay, let's just type it in the top heavy fraction. It was 5 4/5, or it was 29/5. There we go, 29/5. That allowed us to do that. Right, there we go. So you can actually see what it actually looks like. So there is the intersection point. So hopefully, if I can zoom in on that, you can actually see what that is. There we go, 2, 5. That was the point that we found obviously early on in the question. And the bit that we found later on in the question was looking at this point down here, which was where it intersects the x-axis, and hopefully we can see, look, there it is, 14.5. Okay, 14.50. So this is quite a nice program, particularly for these sorts of questions when you're looking at coordinate geometry, just to be able to have a look and actually see it visually, what it actually looks like and where those coordinates are. So I just thought this was worth showing you. I'm going to pull this back up again at the for the final question that we're going to look at, but just a little program there for you to be thinking about when you're moving forward. But let's have a look at the next question. Okay, so this question says the line L is a tangent to the circle with equation x squared plus y squared equals 25 at the point A. The point A has coordinates 3p, where p is positive. The line crosses the x-axis at point B. Work out the area of the triangle OAB. Okay, so we're going to actually have a look at thinking about what this looks like. So if we draw a little picture again, we've got our circle centre 0. We've got a tangent again in the positive quadrant. There we go. It meets at this point here. We've got the centre 0 there. Let's draw all of this in. 0, 0. We've got this point up here, which is 3 something. We're going to have to work that out again. And that is called point A. We've got point B down here, which is our x intersect there. Again, we don't know what the x coordinate is, but we know the y coordinate, which is 0, and it's going to ask us to find out the area of a triangle. Now, we're going to have to find out the equation of the radius, but the triangle that it's actually asking me to work out the area of, I'm going to have to rub this out in a sec, but let's have a look, is this triangle here. Okay, so we're going to work out the area of that triangle there, and thinking about what that means, it means we need to know the base, and it means we need to know the height. Now we will have the length of the base once we get that x coordinate, and we will have the height once we get that y coordinate of A. Okay, so once we get the x coordinate of B and the y coordinate of A, we can do our half base times height to find out the area of this triangle, but we've got a lot to work out to actually get to that point. So let's have a look at how we might get there. Okay, so we are going to have to work out the radius again here. Okay, so once we've got the gradient of that, we should be okay at moving forward with the rest of it. Just a slightly extra final last step here. So let's have a look. We need to get first this y coordinate. So let's sub that into our circle equation and see what we get. So x is 3. So we have 3 squared plus y squared equals 25. Take away 9 from both sides. 3 squared is 9. So y squared equals 16. Square root both sides. We get y equals plus or minus 4. But we know it's positive, so we know it's going to be 4. So there we go. That's our first little bit of working out done there, finding that y coordinate, so y equals 4. Right, on to the next step. Let's get our gradient of the radius. So now we know that that's 4. Let's just put that in here. So our change in y is 4, our change in x is 3. So our gradient is rise over run, change in y is 4, change in x is 3. So 4/3. So our perpendicular gradient is negative 3/4. Put that into our line equation again. We get y equals negative 3/4 x plus c. And again, let's sub in that coordinate there, which is now 3, 4. So we can sub that in. So 4 equals negative 3/4 times 3 is negative 9/4, just multiplying the numerator there, plus c. And then adding that 9/4 over, remember 9/4 is 2 1/4, so add that to 4, you get 6 1/4 equals c. There's a lot of little steps here that we've done previously that I'm sort of skipping. I'm not going to write down 2 1/4 and adding it over and showing all that working out. I'm just writing down c equals 6 1/4 just to speed things up a little bit. Okay, but obviously take things slowly on this one. If you need to write them down, please do so. Right, so plugging that in place of c up here will give us our line equation. So let's put that in. We get y equals negative 3/4 x plus 6 1/4. There we go, and there is our next step here. Now we've got the equation of the tangent. Now we can use the equation of the tangent to find out the x coordinate down here, so we can get the base of the triangle. So that's our next step. Remember, in the y coordinate 0 there. So if I plug 0 in again, so 0 equals negative 3/4 x plus 6 1/4. Let's solve that for x, so minus 6 1/4 from both sides. So minus 6 1/4 equals negative 3/4 x. And now we need to obviously divide these fractions to find out the value of x. Not very nice again, but let's have a look at what we get here. Right, let's get rid of some of this working out. I'm going to get rid of this. We've dealt with that. I'm going to get rid of our gradients. I'm going to get rid of all of this. There we go, and we're at this point here, so let's move this, right. Okay, so let's find out the value of x. So we have negative 6 1/4 divided by negative 3/4, so I'm just going to imagine they're positive again, as they're going to cancel each other out anyway. So we have 6 1/4, which is 25/4, 6 times 4 is 24, plus the 1 is 25, so 25/4 divided by 3/4, and that equals x. And obviously we need to just keep flip change here, so keep the first one. We've got 25/4 multiplied by 4/3, and that equals 4 times 25 is 100, 4 times 3 is 12, so we have 100/12. And if we simplify that, they're both divided by 4. Again, we could have cross cancelled, but I'm just going to go with it as it is. So divide top and bottom by 4, we get 25/3, or 25/3. There we go, and we could always convert that into a mixed number if we wanted. 25 divided by 3, what's that come out as? 3 goes into 24 8 times, so it's 8 1/3. There we go, 8 1/3. And there is our x coordinate. So we have to just knock out enough, actually not enough space to fit that in there. Let's just write that in. So 8 1/3, 0. There we go, and there's our x coordinate. That's our final step there before actually finding the area. So now we've got that, we can find the area of the triangle. And again, remembering the part of the triangle we're actually looking at here. Let's draw that in again. We're looking at OAB. So from O, the centre, to A, down to B, is this triangle here. And if we think about what that actually looks like, if we just draw that out, we've got a triangle. We've got the length of the base now, which is 8 1/3. It goes from 0 across to 8 1/3. So that's the length of the base. And we've got the height, which goes up 4, which we've already drawn in there with our little green right-angled triangle. So our height is 4. So if we do half base times height, or base times height divided by 2, we've got 8 1/3 times 4, and then we're going to halve it. Now 4 is easier for me to halve, so let's just go with 2 times 8 1/3 rather than 4 times 8 1/3 and halving it. So if we just do that, 2 times 8 1/3 would give us 16 2/3. There we go, it doesn't give us any units, so we'll just stick with that, 16 2/3 as our final answer there. Okay, there we go, so 16 2/3. It's not the best colour actually. There we go, let's go with this. 16 2/3. Obviously if it said it was in centimetres or whatever it was, we could put our units there, but it's just 16 2/3 as our area for that triangle. Right, a lot of steps there. Again, don't forget you could have just done 4 times 8 1/3 and then halved it, but I just think it's a bit easier there just to do half of 4 rather than halving 8 1/3. Okay, just to work out the area of the triangle. But there we go, finished on that question. A very, very tricky one. It would be very likely that this would potentially be a calculator question, but there is nothing saying that it couldn't be a non-calculator question. So I have done it non-calculator methods there. Obviously there's a load of steps that we could have saved ourselves if it was calculator. Obviously just being, you know, just what I can see at the moment, this step here, this 25 over 4 divided by 3/4, I mean that'd be super easy to type into a calculator. I've got a calculator in front of me right now, so all you do is press the fraction button, 25 over 4 divided by, press your fraction button again, 3 over 4, and straight away on the calculator you get 25 over 3. Okay, so a lot easier there, and you can just simplify that if you want. Okay, but 25 over 3 is, I mean, turn it into a decimal if you want, but 25 over 3 straight away on the calculator. So there's a lot of steps you can miss there if you're using a calculator. And to be honest, for this particular practice question next, I would encourage you to just do it with a calculator. You know, if you want to challenge yourself and try it without a calculator, then please do so. But it is going to take up the, you know, the majority of a page here working out this style question. Okay, but here's one for you to have a go at. In fact, before you do so, in fact, no, I'll show you on the graphing calculator the answer to the next one, but obviously here's one for you to have a go at. Okay, so very similar question to the last one. Okay, so have a go, pause the video there, see if you can work through all those steps, and we'll go over the answer in a sec. Okay, so the line L is a tangent to the circle with equation x squared plus y squared equals 40 at the point A. The point A has the coordinates 2p, where p is positive, and the line crosses the x-axis at point B. Work out the area of the triangle OAB. Right, so let's draw this in again. Okay, so circle centre 0, 2p, again it's in the positive quadrant, there we go, so there's that. We've got our coordinate here, which is 2 something. We've got our x coordinate over here, which we don't know the y, so something 0, and we've got 0, 0 over here. So we need to find that y coordinate, or the value of p, so let's plug that in to start with. So x is 2, so we have 2 squared plus y squared equals 40. Subtracting 2 squared, which is 4 from both sides, leaves us with y squared equals 36. And then square rooting that, y is going to be 6 or negative 6. And we know it's positive, so we've got y equals 6. So let's plug that in up there. 6. And now we can work through finding the gradient of the radius again. So the rise is 6 and the run is 2. So our gradient is going to be 6 over 2. 6 over 2, which is 3. So our perpendicular gradient is going to be negative 1/3. And we can plug that into our line equation now. So y equals negative a third x plus c. And now we can actually go about figuring this out. So we've got our coordinate over there, 2, 6. Let's plug that in, see what we get. So 6 equals negative a third times 2 is negative 2/3 plus c. Adding 2/3 to the other side gives us c equals 6 and 2/3. Now I can already tell this one's going to be a lot easier than the one I've just done. So hopefully you didn't struggle too much on the some of the harder steps on the last one there. So putting that in place of the c up here leaves us with our line equation, which is y equals minus 1/3 x plus 6 and 2/3. And we can solve this for x to get our x coordinate there. So let's take away 6 and 2/3 from both sides. So minus 6 and 2/3 equals negative a third x. And actually, when we're dividing now by negative a third, that fits in a lot nicer. 1/3 fits into 1 3 times, so it fits into 6 18 times, plus the extra 2 is 20. So we know it fits in 20 times, so x is going to be 20 here. There we go, and there's our value of x. Just to slow that down a little bit, just in case you did do your working out for that one, 6 and 2/3 is 18, 19, 20/3. So you have 20 over 3 divided by a third. Obviously just forgetting they're both negative there because they cancel each other out. And thinking about what that turns into, you've got 20 over 3 multiplied by 3 over 1. Obviously you can just cross cancel there, so you actually only have 20 over 1 times 1 over 1, but if you didn't cross cancel as well, you would have 60 over 3, and 60 over 3 equals 20. So a lot of steps there. Obviously I quite like the logical approach, but you get your value of x there as 20. Now let's have a look if we can draw this in again. So the the triangle that we're actually working out the area of is this one here, and working out the area of that is going to be a lot easier for us because we've got a nice whole number there as the base. The length of the base is 20. The height there we can see is 6, so we've got to do 6 times 20 and divide it by 2. Either one of those is nice for us to halve, so we can just do 3 times 20, or we could do 10 times 6, either one. Okay, but let's halve the base this time. So we've got half the base, which is 10, times the height, which is 6, which gives us an area of 60. Okay, so a lot nicer actually in terms of the final steps there, but all the same parts of the process. Okay, and we get our area of 60. Let's just have a look at obviously what this actually looks like on a graph. We're not going to be able to get the area of the triangle on the graph, but we can draw this x squared plus y squared equals 40. We can draw this line equation which we got, which is y equals minus a third x plus 6 and 2/3. And we can actually see these coordinates here. So the intersection coordinate we got is 2, 6. The x coordinate we got there is 20, 0. So hopefully have those written down, because we're going to flick to the other screen now and actually just have a look at this on the screen. Okay, so if we draw this out, then we had x squared plus y squared equals, what was it, 40. And we've got our tangent, which we're going to have a look at as well, which was y equals minus a third x. Oh, didn't type that in right. Let's get rid of that. Minus 1/3 x plus 6 and 2/3. Now let's not get this mistake again. Let's write it as a top heavy fraction, so it was 20/3. So 20 divided by 3. Right, there we go. And there is our tangent. And you can see obviously, you know, this is quite good for is just checking to get whether you've got your tangent equation right, because you can see it just meets at that one point there, so you know it's a tangent. Obviously if we change this slightly, I don't want to mess around with this too much, but let's change that to 20 over 4 for example. There you go, you can see if you've got something like that, it's definitely not a tangent there because it crosses through the circle at a different point. So let's obviously make sure that is a tangent. Let's go back, change that for 20/3, which is what we got, and there we go. You can see obviously it meets at that point there, which should be 2, 6. There it is, 2, 6. And if we follow the tangent all the way down to the x-axis, that should cross through at 20, and yes it does, that's the coordinate that we found, 20, 0. Okay, so obviously we can't find the area of the triangle from that, but you can see on there a little good visualization of the question we were just doing. Okay, so right, let's go back because we've got one more question to have a look at. Okay, so this is the final question. Now this is quite a tricky one. It's not all the steps of the last one, it is just sort of finding the equation of the tangent. But as you can see there, we have some surds in our coordinates there. Now I did actually look at some of these sort of surd questions on the previous video, but I would encourage you to have a go at this question, see what you get. Okay, it doesn't matter if you get it wrong, does it? But I'm going to go over the answer in a sec. So have a go, pause the video, and we'll go over the answer for this question. Okay, so it says the circle with equation x squared plus y squared equals 4 has a tangent at the point A. A is the point 3/2 and root 7/2. Find the equation of the tangent at point A. Now again, this could be a calculator question. I'm going to assume it's non-calculator because obviously we do have a calculator. Just some of the steps that I'm going to do are quite nice and easy just to type into your calculator. But let's have a go and see what we get. Now drawing this, might actually be easier to draw the circle first. Let's have a look. About the same. Right, so we've got our two coordinates. They're both positive. So again, it's going to be in this positive quadrant. There we go. That'll be just a little sketch of the tangent. We know it's at 0, 0. And our coordinate here for the tangent is not very nice this time. 3/2 and root 7/2. There we go. And that is point A. Okay. Right, so just drawing in our tangent. There we go. Let's work out the gradient. So it goes from 0 up to root 7/2. So the rise, or the change in y, is root 7/2. So we've got, let's write this out. I'm going to do something slightly different here because the change in y is already a fraction. Rather than writing it as a fraction, I'm going to write it as a divide. So I'm going to write root 7/2 as the top, divided by the run, or the change in x, which is 3/2. Okay, because they're both fractions there, it doesn't really help me writing as a fraction over a fraction, so I'll just write it as a divide instead. Now if we work that out, we're following normal fraction rules. We have root 7/2 multiplied by 2/3. You could cross cancel here, but let's just go times the top times the bottom, so we get 2 root 7/6, and then we'll just simplify it. The top and the bottom both divide by 2, so it's root 7/3, and that's our gradient there. Not very nice at all, pretty tough question here. And let's have a look at the perpendicular gradient. So flipping that over for your negative reciprocal, you get negative 3/root 7. There we go, and that is the gradient of our tangent. Now we can plug that into our line equation. So we have y equals negative 3/root 7 x plus c. And again, we've got our coordinates to plug in, so we've got 3/root 2 and root 7/2 to plug in here. Pretty horrendous to look at. So root 7/2 is y, and that equals negative 3/root 7 multiplied by 3/2 plus c. Let's expand that out. So we get root 7/2 equals, times the tops here, the numerators, we get 9/2 root 7 plus c. And now we need to add that to the other side, so we need to add 9/2 root 7 over to the other side. So for c, we are going to have to work out root 7/2, add the 9/2 root 7, and that's going to be our value of c. Now to add these together, I'm going to have to get rid of some of the working out here because we've got a lot, need a bit more space. But to add these two together, we're going to need to get a common denominator. So this left fraction here, this root 7/2, we can times the top and bottom by root 7. That will give us 2 root 7 on the bottom. So if I just write that in, let's write it in, times root 7 and times root 7 on the bottom, and that will give us 7 on the top and 2 root 7 on the bottom. Add 9/2 root 7, and that's going to equal 7 plus 9 is 16/2 root 7. I could leave it like that, but they simplify, so I'm going to simplify the top and bottom. We get 8/root 7. There we go, and that equals c. Pretty horrendous there. Let's just highlight that so it doesn't get lost in all this working out. So there is our value of c, 8/root 7. So we can replace c in our equation up there to finish this off. So let's just get rid of this, just to write our final answer somewhere where we can actually see it. Right, so our final answer is y equals negative 3/root 7 x, that's a bad x, let's write that again, plus 8 over root 7. There we go, and there is our final answer there. Y equals negative 3 over root 7x plus 8 over root 7. And then again, very quickly before we finish, we will have a look at what this looks like on the diagram, because this is one where I would actually encourage using the graphing calculator there and just having a look at what this looks like. So I'm just going to write down our coordinates. We've got root 7 over 2, 3 over root 2. Equation of the circle is x squared plus y squared equals 4, and our tangent equation now, we've got y equals negative 3 over root 7x plus 8 over root 7, and we're just going to use this just to check that it actually is the tangent there, and it does actually look like that. So let's have a look. Okay, so the equation of the circle was x squared plus y squared equals 4, and there is our circle. Okay, so next one, we've got the equation of the tangent, which was y equals negative 3 over root 7. Where's the square root button? Square root 7. There we go. X plus, was it? Plus, yep, plus 8 over root 7. There we go. And there is our line, and we can see there it is actually a tangent. There we go, so we can see we've got it right. Now I don't think this will show it us in surd form, but where is the intersection? Is that it there? That looks like it, yeah. 1.5, which is our 3 over 2, and then 1.3229, which if we just check on the calculator, let's have a look. Root 7 on the top, divided by 2, turn it into a decimal, 1.32287. Yes, so it's rounded it up to the 9 there in terms of our actual coordinate on the program. There we go, so quite a nice little thing, a new little thing for you to have a look at here. You can use this for any sort of coordinate geometry, okay, but it is particularly helpful for this topic, obviously, because it is a very tricky topic, okay? Right, so that is the end of the video. Quite a long one there. Obviously, you probably want to go through that, have another look, but obviously use that program, have a little go with that, see what you make of it. I might do a video on using that for some other topics if you found it useful for this one. But if that video was helpful, if it was useful, please like, please comment, please subscribe, and I will see you for the next one.